Good afternoon and welcome to the solution video for the puzzle Cramped Space, published on May the 10th of 2024. And I considered it an advanced puzzle, not because its proof is very lengthy, but it involves a concept of the radical axis, which I consider more of an advanced thing. Well, what is the puzzle about? What we're seeing here is an arbitrary triangle, and there is its incircle. That's the largest circle, the incircle of the triangle, and there are two other inscribed circles which are tangent to each other, and this is a tangency point. Um, and we also know that the distance from this tangency point to that one is equal to this distance. So that's that. Those conditions are given, and we're asked to prove that this vertex, the tangency point, and this tangency points are in a line, so they are collinear. Well, as I mentioned, the proof involves the radical axis. I thank my ex-fellow Nemo for that. What is the radical axis? Well, if there are two circles, then there is a straight line always called the radical axis, and the points on that line, they have equal power to both circles. So the power in that point to the one circle exactly equals the power in that point to the other circle. Well, in this case we have the two smaller circles, and it is very obvious that their tangency point must be on the radical axis, because there the power is 0. So for both circles, so they are the same. So this point surely is on the radical axis. And now we're going to prove that those two other points are also on that axis. Well, let's begin with the bottom point. Well, from symmetry along this axis, let me draw it, the axis between, let's say, from this vertex to the center of this smaller circle to the in-center, that's a reflection symmetry, so we know that this distance is also over here. So let me draw that. This distance is the same. No, that's this distance, yes. So we know that this length is also the same as that one. In a similar fashion, we can, let's say, draw this symmetry axis through with the other circle. Again, we have that this distance equals that distance, so let me draw it. That's the same, and yes, I mark it as such. So what we have just found, that this red point exactly is halfway between those two tangency points. And because you know that the power of this point to this circle is the square of this distance to the tangency point, and similarly it is the square of this distance. Well, because they are the same, we know that the power of this point to both circles is the same. So we have just found that this midpoint of the common tangent is on the radical axis. That's a well-known property also. Now, for the upper point, we can say that this distance is equal to that distance. Yeah, so if I those two distances are the same, yeah, because of the tangent, they are tangent to the incircle, and we have a reflection symmetry along this axis. So the total of those distances are the same, and therefore we know that again, because the power is the square of the distance to the tangency point, we know that the power of this point with respect to this small circle is equal as the power of with respect to this circle. So also this upper vertex is part of the radical axis. Let me draw it to convince you. This is the radical axis and all 3 points are on it, and therefore the 3 points are collinear. And that completes the proof of the puzzle Cramped space.